If you need to aerate a pond that is located where there isn't electricity available, these are basically your two options: wind power or solar power. And for the home builder, the windmill type aerators would be rather hard to build unless you're extremely handy. But a solar system is much easier to make. And of course, there's times when the wind doesn't blow, and of course at night the sun doesn't shine. But you could make a solar system that charges batteries in the daytime so that it can run at night. So let's start with a solar system, and I'll show you how to build a simple solar aerator. Whoa, I almost forgot. Before we can do that, we better build a pond. This field was a pasture when we bought it 25 years ago, and I've been mowing this field, and all that time took a lot of gas and a lot of hours. And one time my grandson Mike suggested we turn it into a pond, and you didn't have to tell me twice. So we dug some test holes and found bedrock about 5 feet below grade. This looked perfect for a pond. So we started on the pond in late summer, and by the next spring it was full. And you can skip ahead if you find this boring. Some people like to watch this type of stuff. So what you're seeing here is the stripping of the topsoil, and we're piling it up on the property for later use. Okay, the topsoil's gone, and we're looking at a lot of clay here. There's some of the piles of topsoil there. And now the clay removal has started. The clay's being piled up around the far side of the pond. Okay, those bright patches there are bedrock, which is limestone. So that's the full depth of the pond there in the center. Okay, we're just about done there. The dozer's scraping the last bit of clay and piling it up around the edges of the pond. And now we're done. All we need is some rain. And by spring, this is actually the second spring, it was filled up. Mike built that nice floating dock you saw there. For this project, I purchased a 100-watt solar panel. It cost about $90. Now this is the panel only. I didn't buy any kind of a charge controller or any of that sort of thing. I'm planning to keep it as simple as possible. So this 100-watt panel was approximately 33 inches by 17 inches, and it had 4 mounting holes in the frame. The holes were big enough for quarter 20 hardware or 6mm. And what I did was put aluminum angle across here, and then to that mounted angle brackets, which I could then bolt to 2-inch PVC pipe. And since I'm not making it track the sun, we want to line up the holes to put this in due east and west. And for now, for the installation, I just have it mounted vertically. And I'll show you that here in a minute. But eventually what I plan to do is, if this is our PVC pipes and this is our solar panel, I plan to put a arm here from the PVC out to the solar panel so that the angle here can be adjusted. So in the summer you want this angle high up compared to in the winter when the sun is low on the horizon. You want the angle much steeper. And there's lots of charts and things on the internet based on your latitude as to what angle you would want to set it versus the seasons. So that'll come later. I'll show you how I ended up doing that. So next I'll show you the hardware, and then we'll get into the electrical characteristics. The last thing that I just showed you was the rating label for my solar panel. And these are the things that are listed based on a solar flux of 1,000 watts per square meter. So the maximum power the panel will put out is 100 watts. And the open circuit voltage at this radiation intensity is 21.6 volts. So if you just put a voltmeter on the output wires of the terminal, at this radiation level, you'd get that many volts. And if you took those leads and shorted them together, you'd get the short circuit current of 6.5 amps. Now the 100 watt rating occurs with a voltage of 18 volts, that's this point right here, and a current of 5.56 amps. So that's the maximum power point. Now if on a cloudy day where the solar radiation is less than 1,000 watts, then your current capacity comes down roughly proportional. So here we might be at 3.25 amps, and here we might be at 1.5 amps, something like that. But it behaves pretty much as a constant current source until we get out here at the very end. So that's the characteristic that we're working with, and we're going to try and maximize our runtime of our air pump based on the way the solar panel works. Okay, now we pretty much know about the solar panel itself. Now we need an air pump. And it's kind of hard to find good 12 volt DC air pumps, but I found one that may do the job. This is rated 12 liters per minute at 12 volts using 12 watts. So that means it would take about 1 amp to run this thing. And this is the exhaust port, and this is the intake port. And there's a little red dot here telling you which lead is positive. So I actually bought 2 of these so that I'll have a spare, or possibly even run 2 of them at the same time. So to run this thing from a source that's changing all over the place, with the sun intensity and clouds going by and so forth. We need what's called a buck converter, and this device, you can set the output voltage, and the input voltage can be variable all over the place. And it has a current limit function, but you'll want to set that, it's adjustable, you'll want to set that to maximum because before a DC motor starts up, it can draw quite a bit more than its rated current. So there's much smaller buck converters available, but don't be tempted to use a small one because it won't operate correctly when it's first trying to start up the motor. Then you also need an air stone to put in the pond, and the best thing to do is to actually put this in a bucket with some rocks to weight it down, and then possibly have a string with a float of some kind on the top so you can pull it up if anything goes wrong. And then what I plan to do is mount all this stuff in a box. This is a waterproof ammo box that I got at Harbor Freight, and everything will get mounted in here, and this will get mounted on the back of the solar panel. And then I'll attach more tubing here. This is vinyl tubing, 1/4 inch inside diameter, that I got at Menards, and that'll be buried until it gets into the water. So I don't know if it's UV resistant or not, but it should pretty much be protected from UV by dirt and water. So that's basically the items we'll need. Next I'll show you where I got the pump and buck converter and the air stone, and then we'll hook up on the bench and show you how that buck converter works. Okay, here's our little pump. One bad thing about it is there's no mounting holes to mount it. So I ended up sticking double-sided tape on the bottom to stick it in the bottom of the ammo box so it wouldn't move around. I'm going to run this from a power supply here that's set at 6 volts. And this thing should deliver approximately 6 liters per minute at 6 volts. Okay, it's now running at 6 volts, and there's a hose here, and I have a cylinder here with 1 foot of water in it. And notice we're at 0.42 amps. And as I put the hose in the water, we go up to 0.46 amps. So we were running at 0.42 amps when we didn't have the hose in the water, and it went up to 0.46 amps at a depth of 1 foot of water. Now my pond is 5 feet deep max, so my current at 5 foot depth is going to go up by 0.2 amps, and we started at 0.42 amps, so I would expect a current of 0.62 amps when I'm pumping air down to a depth of 5 feet. And of course this is all with the pump being run from 6 volts instead of 12 volts. And I'm planning to run it at that reduced voltage just to extend its life, since it'll be working half as hard and running at half the speed. Okay, here's our buck converter, and I've connected the input to the power supply, and I'm going to put a meter on the output and set it to 6 volts, and that is done by adjusting this potentiometer on the right here. And right here's our meter. Now, with the power supply set at 12 volts, I've adjusted the pot for an output here of approximately 6 volts. Now I'm going to get my hand out of the way, and as I run the power supply voltage up, you see the output from the buck converter changes very little. So that's as much voltage as our solar panel can put out. And as the voltage goes down, the output remains pretty constant. Now if we fall below about 7 volts, our output will start to decrease as the voltage goes on down. So once you exceed the output setting by about a volt, it'll stay pretty constant. So with the buck converter in the circuit, the pump will run pretty constant speed even as clouds are in the sky or the sun intensity changes with the time of day. Okay, now I have the meter connected as an ammeter in series with the pump motor. And we're running here at about 10 volts, and we have our 0.42 amps going to the motor again. Now as I take the voltage up, you can see the power supply current actually goes down, but the current to the motor is remaining the same. So the watts out are constant because the voltage and current are constant to the motor. But as we vary the voltage, it doesn't take as much current to develop that same amount of power. So as we go down in voltage, the supply current goes up. So that makes things able to run from a variable voltage solar cell even easier. So it looks like we could easily run 2 or 3 or even more of these pumps from our 100-watt solar cell. But I'm just going to start out with one for now. Okay, here's everything mounted in our ammo box. And here's the pump, here's the buck converter, and I have the input to the buck converter running to a connector, and I've put the mate of this connector on the solar panel, and that'll come up through a hole in the bottom and plug in here. And I have a hose connected to the output of the pump going through the bottom of the box, and that I can then connect to the tubing that'll run into the pond. Now I have a 1 amp fuse block here to protect the motor in case the buck converter goes berserk. And I have a 5 amp fuse feeding the buck converter in case the buck converter breaks down. I don't want to have a fire in here. So that's basically the arrangement. So I think we're ready to put the box on the back of the solar panel and then do the rest of the installation. So here's our final installation. There's the ammo box. And things are made so the panel can be tilted now. These bottom braces have holes so that the tilt can be changed with the season. Here's everything working on a dismal rainy day. That decoy is tied to the bucket that has the air stone in it in case we got to bring the air stone up for some reason. The discharge point for the air or the wind system is out beyond that tree in the middle there. So they discharge air at different points. Well, now that everything is working, it's time to go get some fish. So here we are at the trout hatchery. The light-colored trout are called palomino trout. We'll be getting the kind in the left channel there. Here's some of the trout that we got in a bucket. So here's Mike releasing the first bucket of trout into the pond. And here goes the second bucket. So then, which is better, a wind aeration system or a solar aeration system? Well, let's compare a few things. The wind system, of course, is a commercially made item, and it's rather expensive, like over $2,000. Whereas the solar system, the way I did it, can be done for less than $200. And the solar system is more modular. You can make it larger if you want to by adding more pumps and even more solar panels if you really need to. The wind system is intermittent. The wind doesn't always blow. In the hot summer days, the wind might not blow for several days in a row. So that could be a problem. The solar system at least runs part of every day. In the video you see how in even very poor light conditions on a rainy day, the solar system could still run even from early in the morning till late in the afternoon. The wind system is a difficult installation. There's 6 bags of concrete in the base, and it takes at least 3 people to get the thing up, and it has to be assembled, and it's quite an operation to put that up. And the solar system, I put it in myself, one person, and it was easy to do. So another consideration, if you have neighbors, is noise. The wind system, at certain wind speeds, the blades vibrate and buzz, and you can actually hear the pump working. It's a fairly loud noise. Now, you probably wouldn't be using either of these near people because you'd have AC power available. So, but it's something to think about. And the solar system's almost silent. Standing right beside it, you can hardly hear it. So, which is better? Well, the best thing is to have both. And that way you're sure of adequate aeration. But if you could only afford one system, I'd go this way. And if you do it yourself, it can be done pretty cheap. Now the solar system can be improved even more by putting in a battery charging system. There's plenty of excess energy available during the brightest parts of the day to charge a battery. And by doing that, it can also be made to run at night. So you can get 24-hour coverage with your aeration system. And I'll show you how to do that in a future video. Well, on April 18th, we had a little change in the weather. It's hard to see, but the solar system is working, whereas the wind system is not. If you look very carefully, you can see some bubbles coming up to the right of the goose. If you got anything out of that video, you could help me by clicking that like button. And if you don't want to miss the next video, be sure and subscribe. And in the meantime, you could watch these 2 videos.